So in this video I'm going to be solving another past paper question related to 3D volumes and areas. Last video which I made on this which was maybe half an hour ago, was quite time consuming, and the explanation was kind of deep. So in this video I'm going to try and take less time and give the best explanation I can give you guys. Okay, so this is another IGCSE paper 1 mathematics O-level type of question, and without further ado, let's get started. Oh, and yes, please do have a scientific calculator next to you, as we will be needing it for the complex calculations related for this. Not really that complex, some of them are. Okay, so here we have, or let's read the question. And okay, so the diagram shows the entrance to a tunnel. The circular arc has a radius of 3 meters and center O. AB is horizontal and angle AOB is 120 degrees, or has a value of 120 degrees. During a storm, the tunnel filled with water to the level shown by the shaded area in the diagram. Calculate the, or question A, calculate the shaded area. Okay, so I'm just going to give some theory over here, and let me first erase this. Okay, and let's use a different color for now. So first of all, when we are going to calculate the shaded area, you guys know that this over here, it's not a complete circle. If it were a complete circle, then it would have been very easy to calculate the shaded area. If this part was also shaded, it would be the formula of the full circle, area of a circle, divided by 2. Okay, that's very simple, but this is a different case, so let's just remove that. Okay, so in this case we have two arcs, or two sectors which are identical. Why? Now the reason to that, it will be I'll show you how, is that, okay, so it's written over here, or OA has a value of 3 meters, and same goes for OB. OB has a value of 3 meters as well. And the reason, or the it's not really any reason, but if we made another point over here X and another point here Y, they would also have the same values as OA and OB. So XO would have the value of 3 meters, and OY would have a value of 3 meters. So, and you guys know that this over here is the radius. The radius is basically just a extra piece of information, is the distance from the center to the point on the circumference. So therefore, like if we were to draw another line, just imaginary line, let's say down here, then it would be, or down till here, it would have a value of 3 meters. It's constant if the circle is drawn properly. Okay, so that's just a reminder. Okay, and now let's move on to the proper logic. Let me just get in a different color. Let's use this. Now, as you know, if X, or angle XOY, would have a value of 180 degrees, and since this area, or this is 3 meters and this is 3 meters, same goes for this part over here and here, or XO and OY. Therefore, I'll just write 3. So then therefore, or since XO, angle XOY is 180, when we subtract 180 from 120, or 120, you would get 60. And there, since this is 180 and they're divided equally among these two sectors, and it would be more sensible if I explained it with triangles. Now let's say that this was a triangle and this was a triangle. Okay, 3 meters, 3 meters, 3 meters, 3 meters. This is unknown, and the reason to why these two angles are congruent is, number one is that 120 is equally, or the 3 meters is shared with this these two sides, okay? And due to that the angles will be equal, so therefore, or the angle XOA plus angle YOB would give us 60 degrees. Now by that logic, or what I said before was kind of high level, so you guys, you don't need to know that, you can forget it if you want, okay? So therefore we divide it by 2 and you get 30 degrees for this angle. So this angle will be equal to 30 degrees and this angle will be equal to 30 degrees. Okay, so now we know the angles. Now we just need to calculate using our these skills which we know. So I'll just move down. So now after using the logic, now let's use a different color. Let's use orange, okay? So first let's calculate the area of these sectors, okay? Now these sectors, as we said, or in the last video I said that the formula for calculating the area of a sector is x over 360, or the angle of the sector over the total angle of a point multiplied by the normal formula. And by using that, or since we know that this angle is 30 and this is 3 over 360 multiplied by pi multiplied by 3 squared, now by using this we'll just simplify this. So this would be 1 over 12, if you simplify this, 12 1 multiplied by 9 pi. Now I do want to give our final answer in terms of pi. Should I? Okay, yeah, let's do it. So what we're going to do, this is basically, or this is also same as 1 over 12 multiplied by 9 multiplied by pi. So what we're going to do, we're going to, like, multiply 9 with this fraction 1 over 12, and when we simplify it we'll get 3 over 4 pi. And now by using our calculators, 3 over 4 pi, we shall get 2.36. And I told you guys that you must do it to three significant figures, 2.36 centimeters squared. Okay, so that's the area of one sector. Now remember, we have two sectors to be accurate, and in order to give the full full answer for them, so we'll multiply this by 2, and when we do so you're going to get 4, or wait, let me just 2.36 multiplied by 2, you're going to get 4.72 centimeters squared. Okay, now that's only these parts, so I'll just try giving you a representation of what. It's the same diagram, I'm just redrawing it. So that's O. Okay, so we know the area of these shaded areas, or these two identical sectors. Okay, now we need to find the area of the this triangle. Now you guys, or if you have studied this topic before, there are two ways of finding the area of a triangle. Number one is by the formula half base times height, or in other ways you can write it like this, base times height over 2. That's number one. And then there's another way, which is half multiplied by a multiplied by b multiplied by sine of c. A and b stand for two sides, and angle c stand for the angle contained in these two sides. So therefore, if you have, or this is, let's just say, so you have a and b, so then the angle must be this, the one which is contained. Okay, so now I'll just solve it, or using, now as you guys can see, we do not have the height, we don't have the height we don't have the height, and we don't have the base. So therefore we do have two sides and its included side, which are these three essential components of finding the answer. Okay, so now what we're going to do, we're using the formula half, let's just okay, a is basically 3 multiplied by 3 multiplied by sine of angle 120. Okay, so we'll do 3 times 3, so half times 9 times sine of 120 degrees, and therefore this would be basically 4.5 multiplied by sine of 120, and the final answer, using our calculators, wait, I'll switch it off. So our final answer would be, if it was a raw answer, it would have been something like this: 9 multiplied by the cube root of 3, all of this over 4. And when you do solve for that, you're going to get, I believe, 3.9. I've memorized, okay, yeah, 3.9 centimeters, no, meters squared. So we have the area of the two sectors and the triangle. So now what we're going to do, we'll just do this, and so now what we're going to do is we are going to finally add them. So I'll just give you an overview. I'll again draw this. We have found this also, so another one, just small diagram. So we have this, we have found basically this is 2.36 meters squared. Sorry, this is supposed to be meters squared. And this is also 2.36 meters squared, and this is 3.9 meters squared. So when we add it all together, we get 4.72 plus 3.9, and when we do add that all together, we shall get 8.62 meters squared.